because we're asking the person itself, and he didn't know, he or she didn't know. So to me, it was that like this.
So did you get a chance to look at more questions over the night?
No, I was taking.
So we saw the first 9 so far. We're at 10.
No, China, the biggest like country now. Where's your Russia? That's
All right, we are back to 9.1.
Russia's gonna just
Solving,
that DLC that
solving
yes.
equations, 2 equations with 2 unknowns, right?
Yes.
9.1. And then the next question, we add 1 more equation, 1 more unknown, 3 equations. So it's double the challenge, right? 9.2. Okay. What shall we do first?
Put everything to one side.
Yes, we need to turn the equations into standard form. Standard means all the variables are on the left and numbers on the right. And if you have any decimals, fractions, you need to clear them. And also, if you have any parentheses, such as this one, you need to get rid of the parentheses. Okay? So, I see minus 3y. I think this needs to travel to the left, right? Okay. And I see a parentheses. We will multiply this out. And I see a y. It needs to go to the left. And then, are you happy with 18 and 44? Yeah. I will keep them on the right side. Okay, let's do what I said. This equation will become, okay, I want to also align the x and y values on the same side, so don't bring 3y to the left. I want x is first, y is left, right? So move 3y to the right side of 11x. This is better. And 18. Okay. I'm going to multiply 3. We just multiply 3 times x and make 3x. And then I have minus 2y. And we have another y coming in and joining these guys. And 44. Any mistakes?
6y.
Right. When you multiply a number with a parenthesis, it's not just the first guy you multiply, you must distribute to each and every term. So this is a mistake. It shouldn't be 2y. It should actually be 3 minus 2. 3 times 2, 6. But before you proceed cancellations or additions, we must combine like terms. These are like, so you have 6, negative 6 of them, another negative 1 in total. Can I do it right on the spot? It will make how many? 7 minus 7 y's. Well, let's move this a little bit. It won't, so 44. Okay, does it look standard format now? X's, Y's, a number, X, Y, a number, X, Y is a number, everything collected and rearranged. Fine? Okay, what is next? What's that? You want to get by itself if you're using substitution method. Okay? So if you're using substitution, you want to get a variable by itself, but they specified a method, another method here. So we need to stick to that method. It's called addition method. Some people call it elimination. So I bet we are going to eliminate something somehow. How? How do we eliminate things?
Make 2 of the values equal the same, like not same, but like opposite, so it would be 0.
Right.
Like,
Walter says we need to make some values the same. What values? You mean they're the same? Look, 3 and 3.
like the same x or
Same
the same
x
y.
and same y. Yeah. We need to make values in front of the same letters the same, with opposite signs just so they can, when you add them side by side, they can cancel out. So how do I do that? First, pick a target. What do you want to eliminate, X's or Y's?
Why?
Why? Why do you pick Y?
They have opposite signs.
Because they are already opposite signs. So if you match 3 and 7 somehow, you will cancel them. Okay, that's a good choice. So how do you get 3 and 7 together or matched?
Multiply the first one by 7, the second one by 3.
Let's multiply the first one by 7, the second one by 3, and 3 times 7, 21. 3 times 7, 21. So kinda you took this number here and that number there, so they will multiply and get the same. Good. So let's do what we said right on the next step. 7 times 3, 21y, that's why we did it, we want to catch them. Well, we also multiply the first one, right? So unfortunately your first term also inflated, but that's a small cost we can handle. And the right side is 18. Agree? No? What's wrong?
We need to multiply.
Yeah. We can't just multiply the left side and leave the right side alone. It's not fair. To keep things in balance, you need to multiply 18 by 7 as well, and we will get a total of 7 times 18, 1, 2, 8, right? 70 and 50, no? Missed the digits. 6, right? Okay, how about the second part? 3 times 3, 9, minus 21y equals 132. Agree? Oh, how great is this? Look, when I add side by side, you have 21, positive 21 of y's and negative 21 of them. In total, how many you have? You have nothing, 0 y. They will eliminate it. Okay? Well, on the x side, however, they are joining together 77 many of x and 9 more, we get how many? 86. And we add the right sides as well, that becomes 258. Right? Okay. Again, solve means you need to get x and y all by itself and set it into numbers. So I'm going to stop solving once I see x by itself. Right now I have 86 of them. So what is the next step? Divide. Divide by 86. So this multiplies, so we need to divide. And we will get x as, do we have a whole number when you divide 258 by 56? No, 86. It's a perfect 3. Okay? Are we done? Yeah, we solved it and we got a number, x by itself. Are we all set?
We haven't found y.
Yeah, there are 2 unknowns. You need to go ahead and find out y. So are we going to redo whole this thing and eliminate x's now and then get y? What is the next step?
Plug in X.
That works actually. You can eliminate x, but there is a neat shortcut. You can simply plug in this x into one of the equations. And once you know x, everything will turn into number except y. You can solve for y. But where shall we plug in? Here, there, or you have to modify the equation, here or there. Where do you want to plug it? 11 into 11x right here, or this 11x? The original one. If you suspect there may be a mistake in your operations here, so you may not want to choose this one. But if you're sure I did everything right, if you trust yourself, you can do this one because this is a much beautiful equation than this one. Yeah, y is already on the left. When you substitute this, it's better looking, but if there is a mistake you made here, it's going to be repeated, so it's risky. So let's follow Nate's up. idea and use the original one. I'm going to take it right here and solve y. Again, we just found x equals 3. I will take this number and use it right here and get y by itself. Okay, so this is gonna be 3. What is 11 times 3? Because you have 11 of them. 33, 18, 3y. Okay, the rest is smooth sailing. You just need to subtract and get y isolated. So subtract 18, you have 15 left on the left side, and minus 3y. Divide both sides by -3, and voila. Y is, what is y? -5. Did you all get the same answer? Any mistakes, any questions? Alright, let's justify this here as well. Again, the answer should be a point. You're gonna pair them up and present in the solution set. The x value you found goes into first coordinate, and the y value you just found goes into second coordinate. Okay, pretty good. Okay, for the 3-equation system, you have 2 options. I'm not gonna solve. No, you don't. I thought 12 is the same. No, you have 1. Okay, we're gonna solve this definitely. Did you work on it? Okay. This is about twice as hard as the first one because we're pretty much doubling the work. I mean, it's not hard. I don't want to say it. It's just tedious. It's just a little bit longer. Okay. So, triple trouble. 3 terms, 3 equations. So what's your idea? What shall we do first? Yeah. What do you mean by solve for z, technically?
Pick 2.
You mean isolate z and get everything to the other side? Or you mean eliminate z maybe? Nate? Eliminate? Yeah. Pick a variable, target variable, x, y, z, eliminate it. And for this, you need to pick 2 equations. You can't handle all 3. Pick 2. So why don't we call them names A, B, C's maybe? This is equation A, B, and C. Pick a pair of A, B, C's. But when you are picking, just see which variables already have a matching coefficient with opposite side, because they are easy to cancel. You don't have to multiply equations with numbers to get them matching. If there is automatically canceling ones, target them first. So which variable and which pair of equations you want to pick? Z, A and C, and eliminate which variable? Z, because look, you have 1z here, -1z, opposite sides. When you add A and C, A plus C, here is A, and here is C minus 3x plus 5y minus z. Look what's this turning into. Cancel, cancel. 1z, -z, gone. These won't cancel, unfortunately. 2x minus 3x is minus x. 5 take away 4, 1y. 23 take away 16, only 7. Okay. All right. The whole idea here is to reduce your enemies. You have 3 targets, 3 enemies. Now you're down to 2. Isn't this great? So this is a great result. So before we lose it, let's frame it, put it in a frame. So we'll go back to it, revisit this. So this is our first result. Now do it again. Pick another two pair, but not the same, and target the same variable. You don't have a choice. This time you need to target z as well. Get another equation like this. But don't pick A and C, it's taken. You can pick A, B, or B, C. Which two you want to take? B, C. Let's go with B, C this time. B plus C we are going to consider. Well, it's not going to be just B plus C though. Because when you directly add them, you won't get to the Z's. Minus 3x plus 5y minus z equals 23. Alright, when I said b plus z, it's not correct because when I directly add these up, z's are not canceling. 2z minus 1z, there's still 1z left, so this is not good. We should multiply one of them, or maybe both of them, with numbers so they can match. So what shall we do?
Multiply the bottom one.
Yeah, multiply the bottom one by 2. In other words, we're not adding b to c, we are adding b to 2c. And this way, can I do it right on the spot? 2 times minus 2 minus z is minus 2z, so they will cancel, get 0z. Minus 2x and minus 6x will make minus 8x. Can you follow? Again, this turns into minus 6x when I double it. When I add 2x to it, it's minus 8x. This is 10y when I double. And add minus 3y to it, 7y. Oh, look at this. No more z, but only xy. Adding 2, 8 plus 23, 31. Where's the mistake?
Got to multiply the
Yeah.
group.
You need to first double 23 because I'm multiplying twice, and add, that's not 31, 54. Okay, now this is our second equation. Now, look what you have. An equation with only two unknowns, another equation with only two unknowns, set it into numbers. Isn't this question just like this? What I did is I spent 5 minutes and converted three equations into two unknown, two equations successfully. Here you go. Here are your two equations. So what I'm going to do next is just repeat the process I did earlier in the previous question. Bring these two equations side by side. So I will move this one here. Minus x plus y equals 7 right underneath this. And I will try to eliminate x's or y's. But unfortunately they are not matching in coefficients. 7, 1, minus 8, minus 1. So they need multipliers. So which one gets what multiplier? Anyone? Multiply the bottom one with negative 8.
Yeah.
So this way we will get rid of which variable?
X.
X. Let's try. It says multiply the bottom one with negative 8. This way negative 8 times negative makes positive 8. Oh, I see you're canceling these. Okay. So can I cancel minus? So I'm just going to rewrite everything. The top one doesn't require any multiplication. The bottom one will do. And change into this. And let's add now. Cancel when you add them. These two add into minus y equals minus 2. 56 minus 56 plus 54 is minus 2. No, we're almost there. All you gotta do is flip the signs, divide both sides by -1 or multiply by -1 if you wish. Get y as 2. Wow, out of 3 fishes, X, Y, Z, you caught only 1 so far. But once you get the 1, you can use it as a bait and get the other 2. So how? How do I use y equal 2? Where do I use it actually? You found this one solution, one of them y equal 2. How do you get x or z?
Use the equation x plus y equals 7.
Emre?
Use the equation minus x plus y equals 7.
Yep. Use one of the earlier ones, but not all the way back. Don't go and use the original one because this is 3 variables. Use one of the 2 variable ones so you can eliminate y and get x. And this looks easier, so let's go substitute y equals 2 here. And solve for x minus x. I'm gonna move 2 to the other side and get 5. This will give us x equals -5. Okay, so far 2 fishes in the basket, 1 more to go. X and y obtained, now you have z missing. How do you get z?
Use one of the original equations.
Yes, we need to go back to original and use one of these now. You can't use this one, it doesn't have z. We already used this, it doesn't have z either. So we need to pick any one of these, anything. So which one has the least numbers? Seems like the first one, A, right? So just use early catches. Y was obtained, this was 2. Z was obtained, this was, no, Z wasn't obtained. Back up, sorry. X was obtained actually, X was -5, right? Okay, just figure out what Z would be. May I clean this part? We no longer need this. This equation turns 2 times -5, -10, 4 times -4, -8, plus Z equals -16. All right, 10 and 8, both negative, turns into -18. Flip -18 to the other side as +18. Z is 16 plus 18, that's also 2. All right, here is the result. All 3 variables are obtained. X is -5, y is 2, z is 2. All you need to do is you cut them, put them into this basket. First row is for x, -5. Second one is 2, y is 2, z is 2. In the same exact order, x, y, z, okay? Any questions? So how can I be sure before submitting into Connect Math, this is right? If you have time, of course, in the test. How would you make sure this is right? Yeah. You can plug in all these equations and see if they really make -16, 8, and 23. Now we have this here. Yeah, how many solutions we got? We got only 1. Is that a mistake? Or something? And what was x? -5. Y was 2 and 2. Okay. All right, that was in chapter 9.2. Any questions? Again, here is a summary. You just pick 2 at a time to get reduced equations. Reduced means you lost 1 variable. Lose the variables, get a pair of equations and solve them again with elimination. Once you get the first unknown, you can get the other two going back and using the middle equation first and the original one last. Okay? Alright, we are starting 2.6, going back to 2.6, and do some transformations. So I want you to first, before doing those questions, review our transformation cheat sheet. Okay? Like, there is a parent function or main function, and somebody added a number to it. What kind of shift is it gonna make? It says vertical if it's plus, I'm sorry, up if it's plus, and downward if it is negative, right? Do you recall these? But if you add or subtract right next to x into the function, it's right or left shift. These are addition and subtraction transformations, but there are also multiplication ones. If a number in front of the entire function shows up, and it's either a vertical stretch or vertical shrink. But if the number is inside that, then we have horizontal shrink and stretch. And if you see negatives, then you start reflecting it along x or y. So we'll come back to this. If we need any of this, we will come back and do it. But let's first see the question and see what kind of transformation is in question. All right, somebody gave us an equation of a graph, a graph of an equation. Okay, it looks like a trapezoid. So how are we going to change this? This is the main equation. We're going to transform it. How did they transform it? They have just took 1/5 of every x value. For example, in all times you used to plug in, for example, x equal 2, you would obtain y equal -8. Now, when you plug in 10, you're going to get that value. So this value is going to happen a lot later. Instead of 2, to be able to get 2 here, you need to plug in 10. A lot things going to the east. Okay, kinda, that's hint. But if you go to the table, table will help you understand better what kind of changes that. So what kind of changes this? They have multiplied pretty much all x values, input values, with a small number 1/5. It's 0.2, small number. The key thing is it's 0.2. 1/5 is 0.2, small number multiplication. So which one on this list points out a number multiplies x in the inside, but small number, and what kind of transformation?
Horizontal stretch.
Horizontal stretch. Still says it's this one. I see why you picked that one, because the number is small, less than 1. And it says if in your function x values are multiplied by a small number, 1/5, then it's a horizontal stretch. I think it's correct. Why not this one? This is also multiplication. But this is a multiplication of all y values, all entire computed values. So you first put 2 in it, compute the function, and then take 1/5. So that's a different story than this one. You are taking 1/5 of input values. Here you're taking 1/5 of output values once f processed x. Okay? And that's a good choice, horizontal stretch. Horizontal stretch means you are really strong and you're stretching this both directions. As I said, same values start to happen a lot eastern and west side. So you're going to stretch it east and west. Pull it, okay? But what scale? How much? Into a scale of 5. As I said, when you are, this used to be 2, now it has to be 10 times, 10, so it's 5 times bigger. Okay? So stretch this 5 times to right and left. Can you visualize? here is what we need to do. As you notice, there are 4 bold points here. I didn't mark them just randomly. It will help you stretch this in an algebra. Locate their coordinates. So this looks like 5, 0, right? I see 5 in x-axis and 0 on y. And this is 3, what, 8, negative 8. And this is going to be negative 3 and negative 8. And what is this point? Negative 5, 0. Now remember, you are multiplying all x values. Stretching horizontally means you're only multiplying x values. Y won't change. So the height of this object won't change. You're only horizontally enlarging it. So x values will be quite big. All you need to do is multiply this by 5 times and compute the new location. It's going to be somewhere here, because it's negative 25 now. I know it's a lot more, but I'm out of space. So this point moves here. How about this guy? What is 3 times 5? 15. So it's going to move somewhere here. Okay, this point is going to move somewhere here. 5 times bigger is 15, 0. That one is going to move 5 times to the right, 25. Now connect these 4 dots, because the shape is not deformed. It's still a trapezoid shape, okay? So all you need to do is now connect those 4 dots. Okay? Of course, it's a lot wider, but I think it makes things clear, right? Okay. Again, it's a multiple choice question. Don't go with trial and error method. I need you to first work on a paper, then go choose the right option, as I did. I didn't pick at these. So which one in this 4 choice is the right one? A, B, C, D. It seems like not this one. Ours is upside down. B is a good one. This is not. How about C? It looks like a lot narrower. Of course not. I just want to justify it. Is this point negative 15 and 25? Yep. Negative 25, negative 15, negative 15, negative 25. Yep. Seems like part B is the right choice. Okay. All right, there are more transformations on the way. This time, verbally, they are explaining us what's going on with the function. There is a parent function given x cubed. You know very well the graph of this. You're going to graph this and make these transformations. And finally, this equation will turn into a totally new one. And you're going to write down that equation here. And here's your guidance. This tells you what kind of shift makes changes, what kind of changes may happen in your equation. Like if somebody shifts upward, you need to add a number to your equation, etc. So I'll give you a minute to think about this if you haven't done so. Please copy this, and I will switch to your guidance sheet here. First, you're shifting 5.7 left, reflecting along Y, and shift up 6.1. All right, first answer will get a credit. First right answer. So speak up if you have one.
Can you go back to the question?
This one? Yeah, speak up. I mean, it's okay. If it's even you're wrong, you won't lose anything. Jay?
Would be y equals negative x plus h in parentheses with 3 on it.
What is H?
6.1.
The 6.1, you want to switch this to? What is 6 point, oh, okay, 6.1?
The negative on the
Inside?
by the x.
Okay. That's it? I don't see you have used 5.7.
Is it
I'm real.
Mariah?
Mariah, yeah, sorry.
Okay, parentheses, y equals x plus 5.7, and then cubed plus 6.1.
Okay, there's a second answer. Do you want to revise those?
Y equals negative x plus 5.7 in parentheses with a cube on the end plus 6.1.
So you switch 5.7 and 6.1 out. The only difference is yours doesn't have a minus.
Yeah,
He
it
has
needs a negative.
where is your negative?
Minus x.
Inside?
Yes.
So you agree with him?
Yeah.
Okay. So you'll split points. Okay. I don't know that right. So if you have a different one, say it. No? You all agree on these answers? Okay, let's justify. This is our parent function and it's going to mutate, right? Change to what? First we are shifting 5.7 left. Let's see what shifting makes. Shifting left. Oh, it's going to bring whatever the shift amount is, that shows up right next to x. So, but when you're doing this, be careful. You need to first empty out all spots with x's. So x was sitting underneath this cube, so it's empty box first. It's a ghost. It's gone. And you bring x back, how? With an attachment, x plus or minus whatever that number is. It's plus, by the way, sorry. Plus h, which is 5.7. So you're bringing it back as 5.7 here. Now, since you have cleared one variable and put instead 2 back under the same power, you must definitely use a parenthesis to say cube belongs to both one. Otherwise, if you don't use a parenthesis, it looks like cube belonging to only 5.7, which is incorrect. Okay, that's step 1. Looks like similar. Next, we're doing the second one, reflection across y-axis. What kind of change happens if you reflect it? There are your reflection along y-axis, right? Yeah. It says wherever x's, or how many x's you have, get out of them, get rid of them, and bring them back with a minus. So I'm first emptying all pockets with x's. There is only one room with x. So it's empty now. 5.7 stays. This is gone. but it comes back with a minus. Looks like you guys are on the right track. And finally, shifting up. It's the first one, very first one. Oh, it's just adding that number to the very end of the entire equation. It's outside, you see, it's not like this. So we will just on the outside add that thing. What is that? Number 6.1. Alright, looks like you both are right. Okay? Is it understood? That's what you're going to enter into the room. Okay? Well, there is a very similar question, but different transformation. So you have 1 minute again. Do this one next. There's the list in case you need it. Anyone? Matt?
Negative cube root.
Okay.
1/5 x. Erase the x and the
1/5 x. Like this.
plus 1
Outside, inside,
inside.
inside. Okay, next. Any different answers? Do you agree? Last call. Any different answers? Okay. So, first, we are going to shift to the left. Shifting left means emptying all pockets with access. There is only one. It's under the cube root. And we bring it back. How? Shift left again. You put that number next to x and add it to x and bring back. So it's x plus 1. We are shifting 1 unit, so it's x plus 1 under the cube root. Okay, next. We are taking this and applying another transformation, but it's a stretch. There are two kinds of stretch, vertical and horizontal. This one is horizontal. We've done in the previous trapezoid question, right? This one, we stretch it horizontally so you know what's going to happen. So we will pick which one horizontal stretch? Which one? This or this? Which one is it, horizontal or vertical? Horizontal stretch. Okay, horizontal stretch. Which one is horizontal stretch? Which one? This one, right? But what was the number? 5, correct? So if they are enlarging 5 times sideways, what is your A then to come here, replace X? Is it 5? Is it 5? No, it can't be. Look at this. A has to be less than 1 so you can stretch it. You're stretching it 5 times bigger. That doesn't mean this is 5. It's 1 over 5. So you take reciprocal of that number, put it under 1, and use it in F. So that was a trick. I thought you could fail, but you caught it. When you're bringing X as AX back, you need to do that A not 5, but 1 over 5. Okay, so right now everything looks good except the last one. We are going to reflect across x-axis. Reflection across x. This time we are using this. So it's a minus sign but not in front of x. We are not taking x's away and bring it back minus x. We're not touching x's. You are putting it in front. Okay? So you take the whole f of x, this is whole function, but you put a minus in front of it. Okay? Any questions? Alright, moving on. 2.7, the next section. Somebody gave us a graph, has several pieces together, making sharp turns. We are going to investigate on over what intervals this function is increasing, decreasing, and constant. So one key thing you need to pay attention here is when you're looking at increase and decrease, don't look up where the arrows move. I mean, it looks like most people think this is increasing because it's going up. No. Imagine you guys walking on this path from west to east, from left to right. This is you. Are you sliding when you're walking from left to right, or are you climbing? That's the question. So when I'm here, for example, it feels like I'm sliding, right? That's a decrease, not increase, although it points up. This is a decreasing path. Here, when I'm going from west to east, what kind of change do you feel? Are you climbing up a little bit? Yeah, this is an increasing zone. How about here? That's look like plain path. Seems like constant to me. Question is, yeah, we can visually see where things happening, where things happening, but how do you write this mathematically over intervals? That's the question. You need to change this, describe this region over x-axis, because I've seen some people are doing it over y-axis, but no. When you're locating your region, you are looking up x values. Over what x values this change is happening? And you don't need strong math here, you just look and say. So where do sliding start and where does it end on x-axis? Anyone?
Negative infinity to -2.
Yeah, since this end going endlessly to the left side, imagine you smash this to x-axis, you're starting all the way here, and where do you stop?
-2.
And you stop here because you're starting climbing there. So this is your first interval increase. Since this end is endless, it's negative infinity, this end is 2. So, I'm sorry, I said increase?
Yeah.
Decrease, thank you. Alright, next, where are we increasing? Here to there, right? So I open a new parenthesis. This is where how far do we go?
2.
Up to 2. This is increase. Yeah, this is decrease. Let me fix it. Sorry. Alright, what is the last window? There is one spot left. Little gap here from where to where? 2 to 3. It's a constant region. Again, take key thing. Look from left to right and mark your intervals on X, not Y. Domain values. And when you're typing in increase and decrease intervals, always open intervals. This is sometimes increasing, sometimes decreasing, and sometimes constant. Interval notation, it's increasing from, you said, what was it? Oh, this is, by the way, it's not 2. What is this number? Yeah. -2. And then you're picking up again -2. So you're increasing from -2 to 2. And then you're decreasing from all the way left to, all the way left is -infinity to -2. And finally, you're constant on the final little bit small area, 2 to 3, right? Again, we do not use brackets on instead of parentheses because this end value, right, this deep down value is neutral. You cannot include it to the decrease or increase. This guy is neutral, so we always use open parentheses on the ends. All right, we are out of time. We will continue working on this. Please, before coming to class, take a look at these questions so we can go faster, okay? Any questions, Andrew?
Who's Andrew?
You asked that question.
I know.
Okay.
Is he a recognition?
See you later.
He's not real. Andrew alive.
Remember to work on question 19.
So you're at 90?